Welcome to homework.
So this is problem 24.47. In this problem, we have a lens with the refractive index N2 equal to 1.52, and this lens is coated with a coat which has a wavelength, which has a refractive index 1.25. And when we try to look at this lens, we observe that it looks like a green lens. So the most clear wavelength is actually 570 nanometers. Okay, and the question is asking what should be the thickness, the minimum thickness, so that it looks, so that this wavelength is the most pronounced wavelength when you look at this as a lens. So let's imagine we have a light ray going like this. So outside the lens and the coat, the refractive index is actually n equal to 1 because this is air. And so because this refractive index of the coat is greater than the refractive index of air, there will be a phase shift of 180 degrees when lights reflect from this interface. And when it goes inside and then reflects from the second interface here between the coating and the lens, because again, this refractive index is 1.25, which is less than 1.552. So it will again go through a 180 degrees change of phase. So actually, this reflected light from here and the other reflected ray from here, they will actually be in phase. Okay, and so if we want to have a constructive interference for this particular wavelength, the the path that the light go through inside this coating, which is 2t, where t is the thickness of the coating, should be equal to a multiple integer of lambda. And because we are looking for the minimum t, so this multiple integer, we will assume it's 1 because this is the lowest it can be. So tt should be equal to lambda. But actually, lambda inside this coating is different than the lambda outside this coating. So this is lambda n. And we know that the wavelength inside a medium is actually the wavelength in air over the refractive index of this medium. So 2t is actually lambda over n. Okay, and hence, well, this is T minimum again. So T minimum would be just lambda, which is 570 nanometers over 2 times 1.52, which is, sorry, it would be actually 2 times 1.25, which is the refractive index of the coating, and this will equal to 228 nanometers. And so this is the minimum thickness that the wavelength that the coating can have, and so that the most pronounced wavelength would be the 570 nanometers. So again, the main idea here is just to realize that actually the light rays here go through a phase shift, a 180 degrees phase shift here at the first interface and also at the second interface. So they will actually, the reflective beams will be in phase. And so the condition for a constructive interference would be a multiple integer of lambda.